Okay, here's the latest Tinker project here. My DX Engineering 40 meter vertical I want to use on 30 meters. So I need to make a matching network, which I did. And let me show you how this works. Okay, so here's what we got going. A simple little LC matching network at the base of the vertical. That capacitor is from a command set, an ARC5 command set, and some coil stock which I can cut down because I'm only using about an inch of it. And here's what the MFJ says. Let me turn it back on here. What I did was use the NanoVNA, plugged right in there, measured the impedance, and then designed a matching network to set it up for 50 ohms. I will go in the shack here, and I have the MFJ out here because it's easier to see on the camera. But the NanoVNA is quite the tool for this kind of stuff, and many other things too. In fact, I used the NanoVNA once I calculated the values of L and C I needed to set up the coil stock and the capacitor using those values, and it was right on the money. So I'll show you what it looks like in the shack now. So here's what it looks like in the shack using the NanoVNA. We're sweeping from 9.5 to 10.5 megahertz, and the little blue marker there is at 10.120. I don't know if that's going to be readable or not, but the SWR is very low. Impedance is 47 plus J.5, so does a good job of what it's supposed to do. And of course the whole point was to get a dedicated antenna to mess around on 30 meters with, because I'm going to be spending a lot of time there. Anyway, here's what I came up with, if this is even readable. But the measured impedance I started out with was 270 minus J157. And there's two ways to match it. I chose the top version with the inductive input and the cap to ground. So this is actually a variable capacitor, which is about, I think, 30 to 130 picofarads, something like that. Use the NanoVNA to measure the amount of coil, to select the cap. Plugged it into 270 minus J157, and we had 1-to-1 match at 50 ohms. So the NanoVNA takes all the guesswork out of that kind of an operation. Pretty cool stuff. Keep tinkering, everybody.